Welcome back to another episode of Beyond the Curve. Today we are joined by two special guests, Jermo Konke and Meike Faulhaber. And we got a treat for you today. We're filming at World Headquarters in Germany. So you ready to go beyond the curve? Let's do it. Today we are unpacking probably every audiophile's favorite topic. We're talking about transducers today. And transducers, when we think of them from a 10,000 foot level, or however many meters that is, we're thinking about how a device that transforms energy from one form to another and lets us enjoy music. But I think we have to go a little bit deeper and build up a foundation of knowledge. So by definition, Jermo, what is a transducer in your day-to-day?
Yeah, in my day-to-day, so there's of course out there millions of transducers, but for us, we mainly talk about dynamic transducers that are supposed to transform electrical energy into acoustic energy, or let's say it's mechanical energy that then radiates acoustics, if you will, or a sound wave that we then hear as music, hopefully. And it also works the exact other way around. So if you play music around a dynamic transducer, then it will also move and actually induce some a current that will then can be recorded as a music signal. So microphones and headphones work the exact same way, and it only depends whether you push a current in or whether you just take it out, if you will.
And let's clarify something else. Thank you for that. Transducer and driver, because we use these terms quite a bit in the audiophile world. There is a bit of a difference, or maybe some clarification that should be provided on what the drive unit is versus the overall transducer. Can you shed some light on the differences between the two from a technical standpoint?
Yeah, I don't know if there's a technical definition for driver. For me, the transducer would really be just the core elements. So what Meike would also simulate a lot. So the magnet, the coil, and the diaphragm. So the plastic sheet where the coil is attached to, if you will. So these would be for me the main elements of the transducer. And then some people would take the entire basically piece you see in a headphone as a drive unit, and then you have the entire plastic chassis within it and the damping material and so on, which can vary from headphone to headphone, of course. I believe that may be a reasonable, let's say, a differentiation between both parts, but I think actually it can be used interchangeably more or less.
And so we're going to jump right into a hot topic. Sennheiser has been known for, in the headphone world, for outstanding dynamic transducers, and it's been a core platform for which we've innovated and created some of the benchmarks of the audiophile community, HD 600, HD 800, and down to the in-ears. We've always, for the most part, we've used dynamic transducers, with the exception, of course, of Orpheus and HE1, which is an electrostatic platform. Tell us a little bit about dynamic transducers, and have we explored all there is to explore with dynamic transducers? Are we ever going to venture into other directions? That's a question from not just YouTube and HeadFi, but also meeting people in person at Can Jams and the like.
Yeah, so thanks for the great question, and I will have to correct a little bit there. So we had, back in the days, we tried out a lot of stuff, and we actually also had electrostatic headphones that had a permanent charge in them. So they were called the unipolar headphones, for instance, I think in the 70s or something. And so we don't just always do dynamic transducers, but especially like 20 years ago and before that, it was really a lot of engineers just trying out stuff and putting it on the market and seeing whether it flies. And nowadays we are a little bit more analytical and in our approach, and we do not want to put too much business risk into trying out funny ideas. But to answer the core of the question, will we ever do something else, or are dynamic transducers at their limits? In my opinion, we'll certainly develop dynamic transducers even further. So I do not think we are even close to the limit of what we can achieve. I think there's a lot of challenges, unfortunately. So one thing is conceptually trying to improve it, and you think, okay, maybe if we wind the coil a different way or something, or make it lighter, then it's going to be much better. And that's a theory. and then you have to do a proof of concept, and maybe that works as well, and then you have to put it into practice and actually manufacture it, and that is where the challenge is. So actually the fun trying out stuff, that is 10% of the work, and after that you're spending 5 years trying to bring it into manufacturing. So whenever we would do something like that, then it has to be really scalable, really. So we cannot just build it into one model of headphones, but it has to be in 10 or something. The other question is, do we ever dabble into other transducer types? So first, AG1, as you said. So generally, we believe that is probably from a physical standpoint the ideal way of transducing an electrical signal into acoustics. So you have a very large diaphragm, which we think is important. It is extremely light. You don't have a coil. It's really just a sheet of plastic, if you will. So it's really almost weightless, and you only have the weight of the air in front of it. So this is what we think is as close to the ideal as we can get. And of course, there's always different ways you can go around working against that ideal. So the AG1 and the old Orpheus, they sound markedly different, and both have their fans. So not one is better than the other, in my opinion. I personally prefer the old Orpheus, for instance. But we will certainly always try to go for the best sound there is. And now and then, for us, that's an electrostatic headphone.
Meike, speaking of physical attributes of a transducer, specifically its diaphragm, do you find that geometry, thickness, and the materials used in a transducer affect the sound quality as much as, say, the acoustic chamber or some of the other implements that go into a headphone?
That's a tough question, actually, but I think it's both. And the material of the diaphragm is really affecting the sound enormously. So you can, if you add some damping maybe in the material of the diaphragm, you get a really different outcome of the sound waves, and you can, I think, that you have other areas that are affected. The chambers, that gives the basic frequency response, and the surrounding of the headphone or the cushion gives the basic frequency response of the headphone. But the diaphragm, especially the material of the diaphragm, gives us little details, especially in the high frequencies, or the last thing that you maybe get or not get via listening to a headphone. I think, yes, you can say it that way.
Yeah, and it's really it's really awesome also to see that you can really try to optimize always for frequency responses and so on with different materials, and then you spend a lot of work with validating that, and then you go to listening tests with basically the same headphone. It is different diaphragm materials, and they measure basically the same, and yet everybody says, well, they sound wholly different. Yeah. and that can be really tiring for acoustic engineers, of course, if they put years and years of work into now trying to find a new superior maybe diaphragm material, and everything measures and simulates perfectly, and then they then they go into listening tests and it's no good.
Oh yes, we had this. No? So we tried to do a really good transducer, and we gave it for listening tests to Jermo, and they say, no, maybe not. But it's the measuring is so good. But no, I don't like it.
At what point do you determine that a transducer sounds better than the one it's replacing, or, for example, the next version of a headphone? At what point do you say, yes, it's better? Is it based on metrics? Is it based on your perception of the sound?
It's really a personal thing. The decision is not made by measurements or by some process that is written down or something like this. I think that's really the human factor, or several people have to agree that this is really outstanding. So, or do you agree?
Yeah. So of course we would always start with some sort of mission. So why do we want to touch or improve something, for instance? and sometimes it has to do with something you can measure. So for instance, when we developed the HG660S2 in the beginning, the acoustic engineer basically put on my head the original HG660S, gave me an equalizer and said, well, dial as much bass in as you want. And then I was dialing and dialing and dialing and thought, oh, well, I don't know if we'll get there. And nonetheless, I think we got pretty close to what I wanted to have then. Yeah, but that may be the starting process that we say, okay, we want to have a different frequency response, and these are the sort of adjustments that we think make sense. That's a very important one. And then the engineers try to make sense of it and try to implement it, and then we have to listen and see if it actually made sense in the end. And for that, we have an expert listening panel, and it's always very humbling because very many people in there have more listening experience than I'm alive. And I'm in the end the decision maker, and the people tell me, well, yeah, I don't think it sounds very good. And it's never a whole picture where 100% people say, yeah, this is 100% better. It's always people having different opinions. And usually you get like 70 or 80% majority where you know, okay, this is really where we want to be. Yeah, but it's in the end always the listening experience. And if we are really serious about it, of course, we do blind tests, and then it can get really, really hard because especially if you then also equalize the headphones so that you really have only the technicalities, if you will. And it's still the same acoustic system. It should be roughly the same frequency response. And then you have to listen to something like how fast the transducer is, if you will, or whether you hear a little bit of distortion in there.
Here's a question that we get. We received it on YouTube, but also very common in Reddit and on HeadPhi. Why don't we make a multi-driver listening solution, specifically an in-ear product?
Yeah, I think we would have an outstanding expert here at the company. His name is Andre Michaelis. He's been with the company for 40 years. He worked on the original Orpheus, and for the past 15 years, he's been very concerned with miniature drivers, and especially the ones that Meike brought here, for instance. This is our true response transducer, and probably the camera will have a hard time seeing it, but it's really, really tiny. And so we believe this is really the best option for reproducing sound in a small form factor. So it really ticks all the boxes of what we think are the measurable components of very high sound quality, and we listen to it and we hear these, we confirm basically by listing also these assumptions made on technical aspects. And so there's nothing left for us to improve on that.
So transducer size is important, and specifically diaphragm size. In the audiophile world, we look at specs, and there's a general perception that bigger is better, but I don't think that's always the case. Meike, what are some things that you see when using some of your equipment for simulation and modeling, that when you go too big, what happens?
Oh, when you go too big for over-ear headphones, for example, so the really big ones that you come to the point where where the diaphragm has some breakup modes or breaking modes, then in the really mid-frequency range, where the diaphragm, if it's too large, begins to move unexpectedly, or I don't know, where there's it's not like a really smooth up and down movement anymore, but it can this breaking modes where it's go away like dancing a little bit, but it's no, but it's in the mid frequency range we don't want this, and if we cannot avoid these breaking modes, but we want to really control it. That is in a frequency range where they're not that hearable, and where they are can be more controlled and not that don't come that often.
Yeah. Yeah. And also to expand on it, so why is bigger always better? That's I think also, or why why there's a good reason to build large transducers, let's say it like that. So the first one is that the bigger it is, the more plain the sound wave will be that is emitted, and that will be more akin to a sound wave you would get from a source far away. So if you have a very small source right next to your ear, a so-called point source, then actually there will be a curvature of the sound wave that reflects within your pinna, and you have different reflections in there, and your brain automatically knows it, that it's a small point source. So if you snap right next to your ear and a meter away, you immediately know it. And so if you were to build an over-ear headphone with a very small transducer, then you would always know, okay, basically the sound is within my head, because your brain can't make any other sense of it. And if you have a very large one, then there's an impression, oh, there's loudspeakers in front of me, because the sound wave is so plain and emulates it so very well. So that is the psychoacoustic reason why a large one would be better. And in a technical context, if the transducer wouldn't have any breakup modes, then if it had a really, really large surface, then it would have to extend a little bit less to produce the same sound pressure. And that is, of course, super, super cool. So the less distortion, the better the sound, ideally. The problem is, of course, that once you go too large, then you get these breakup modes, and so you have to balance overall low distortion in the bass and generally across the frequency response with the distortion and impurity induced then by breakup modes in the mids and highs. And actually, I just wanted to highlight some of these transducers are unfortunately a little bit broken, but you have here like a historical lineup of different transducers, which are each like 10 years apart. So this one, the KDH580, is, I guess, from 92 or so it was developed. So the product, I think, launched in 93. Then the SYS38, which has, by coincidence, the exact same diameter, was like a mass-producible version of it 10 years later. And then the most modern one, which was first introduced in 2012, which is basically a hypercharged version of them. So it uses a much stronger magnet. It has a very special magnet chassis, for instance, with ventilation holes in the back, which you unfortunately can't see so well. But there's a lot of innovation in there that makes this transducer really, really high performance. And they have all the same diaphragm size. And the reason is because we believe that this is pretty much the ideal compromise between transducer size and sound purity. So once you go far beyond the 38 millimeters and you do 45 or 50 or something, suddenly funny stuff happens, if you will, unless you do a very, very smart solution like the ring transducer.
Thank you for that insight. So speaking of compliance and the performance of the transducer, especially with regards to low frequency sound, we've got a question from YouTube that I think you'll enjoy. And the question is, where does the impression of bass impact and dynamics come from? He says, or this person says, I'm under the impression that two headphones with similar frequency response in the lows can have or not have a sensation of slam. Where do you think that comes from? He says, my guess is that it's the weight and stiffness of the driver and baffle, and maybe even the clamping force of the headband. Any insight on that?
I guess I'll take it as a start. So the idea that some headphones sound a little bit flat, even though the bass isn't really there and it doesn't feel quite punchy, and some others that may have a similar frequency response, they sound really energetic, and you really feel the kick drum when it comes in. And that's a super interesting question. My personal opinion on this is that it's mostly reliant on, so of course, the entire acoustic system will have an interplay, but I think on the transducer level, I think there's a strong interaction with basically the motor. So if there's a lot of linearity in there, if you will, so that you have a fairly compliant surround, and then that the coil has a lot of travel without diving out of the magnetic gap and losing its drive. And that is sort of it is a bit of a stretch scientifically, because normally you listen at loudnesses where you wouldn't really measure these distortions. So oftentimes it's you would measure, or you would listen at 70 dB and you could still hear a punch in a headphone, while like you would only see a loss of linearity when it plays at 100 or 110 dB. So it is really hard to draw a direct connection there, to be honest. Nonetheless, oftentimes also when we just generally think about distortion in the mids, for instance, oftentimes you can hear impurities even if you listen at like 70 or 80 dB, and the impurities only become really spikes that you can measure well at 90 or 100. I listen to a lot of headphones by now, and I can often hear really a difference between something really sounding pure and something being a little bit scratchy, if you will. And that is what you would hear in the mid frequencies. So that is my personal take on it. And that is also, I think, how it's frequently with loudspeakers, for instance, that it's really a lot about motor optimization.
This is a question from Instagram. Do you think it's mandatory to give your transducer a burn-in period or a wear-in period? This is something that's been widely discussed. What's your philosophy and thoughts on that?
Yeah, that's also funny, or not a funny question. It's an understandable question because it's discussed a lot. It comes from a real background, and that is loudspeakers again, where the coil is really, really heavy in the subwoofer in particular, and so it doesn't stay in place just by the, let's say, by the stability of the diaphragm, but it has to be held in place by a special holding device, if you will, a spider, as it's called, and it's made of some sort of rubber material usually. And that rubber material actually wears in after a while. So in the beginning it is a little bit stiff, and then it's advised to play some noise or low frequency signals for a while, for a few hundred hours, and then it's loosened up, and then it plays at the desired performance. So that is where that idea comes from. And if you look at these headphone transducers, then actually they don't have a spider. So the diaphragm itself is basically stiff enough, or it is robust enough to just carry the voice coil in any direction without the coil being seriously displaced, if you will. And since we do not have the spider actually burn-in does not exist in the real sense for headphone transducers.
We actually had a question almost verbatim, and I'd like to unpack that. The question was, are my 7-year-old HD 700s deteriorated? I use them on a daily basis and replace the pads and cables. Do headphones have an expiration date?
Yeah, that's also a very cool question, and it's one that I'm actually proud to answer. So I'll just take out the HD580 here that we have, and I don't know this. Oh, this is an island-made one, but in the beginning they were actually made in Germany, and that was now pretty much exactly 30 years ago. And these headphones that are so old, so literally older than me, they still function perfectly, and that is basically the main gist of my answer. And there are some like sometimes if you actually physically damage a headphone, then obviously it will stop working. Or if you really have it in just a case for 20 years and then the foam deteriorates and then gets sort of stuck on the transducer, then that's not super nice. So there are some ways to break a headphone. And for electrostatic headphones, there's also some very niche edge cases. But for the most part, our dynamic transducers are so super robust that they can be used by your grandchildren probably.
I would imagine the first point of failure on any transducer would probably be the diaphragm, right? What are our diaphragms made of? They seem, in this case, they last 30 plus years. There's plenty of HD414s still in operation. Tell us a little bit about the makeup of those diaphragms when it comes to composition.
Yeah, so first I would just qualify your imagination. So you said the first breaking point would be the diaphragm, and most of the time it's actually the wire leading to the voice coil. So you have a very, very thin wire that leads from the outside wiring to the voice coil. And if it has to excurse a lot, and then that's very stressful to a wire, and it's made of metal. And if you stress metal beyond its bending point a lot of times, then it becomes harder and harder and harder. And after a while, it just breaks. And luckily, that doesn't happen in real life applications because we really optimize our transducers to function well until you go to 120 dB for hundreds of hours. So that is really a scenario that hopefully nobody does to their ears or their headphones. And it doesn't come for free. So like 30 years ago, our wiring wasn't very optimized, and then the headphones weren't quite as robust. And then some of our senior engineers thought up a very smart idea in which way the wiring needs to be basically laid so that it's perfectly robust and can follow the excursion as best as possible. This geometry is still industry leading, and so that's why it's super, super robust.
We're so thankful for both you, Jermo, and you, Meike, for spending some time with us and sharing some of that expertise, giving us a little inside peek at the whole world of transducers. It's quite fascinating. I also want to thank our community for submitting some of these great questions. We hope they've been helpful and that the answers have been useful for you in your audiophile journey as you look to find the perfect sound for you. I would love to revisit this topic again at a later date, but other than that, we'll see you in the comment section of YouTube, HeadFi, Reddit, and all of the other hi-fi communities. Until next time, thank you so much. Thank you for going beyond the curve with us. See you soon.